something 200, weight also something 300 kind of the thing. Channel color is nothing but you want to be showcased in the RGB format or RGB color format with respect to the color image, and you want to be showcased as a grayscale image or black and white color image. So we had two different types of the channels. So whenever you encounter any kind of the RGB kind of image, at the time, what you are going to do, you have to convert to the grayscale image, that is black and white image. So why we are doing this? This is also one of the questions in your head. So we are doing this because of what will happen at the end. We are going to be convert the each and every pixels in terms of grayscale, you can say grayscale, and also the black and white image, because of you need to write some of the numerical format nature in terms of the each and every pixel like this. So it will starts with white is going to be represent pure white, you can say this is a completely pure white, right? This is all the pure white. So this pure white is represented as 255, and pure black, you can say dark black, is represented as 0, or any kind of the numeric format we want to be represent in terms of the density with respect to the whatever the nature we had. So you can see this is some kind of the human kind of the image we're going to be understood with respect to this image. I would suggest you to take a brief look at about this pixel kind of the thing. This is some kind of the heading nature, and this is some kind of the eye nature, and this some of the nose kind of the thing, right? So we can, as a human being, we can observe this, but as a system, it cannot be observed this much of the patterns according to the whatever the image you going to be passed into the system. So for that, it's going to be divided into each and every pixel into some number format. So you can see this is going to be somewhat in some number called 157, because of it has a region, or it has some density color with respect to the white and black, whatever we just now learned. White is going, pure white is going to be represented as 255. It may having the range maybe corresponding to the dark kind of or yellowish kind of, you can see some of the colors having some light black color, some of the colors having light white color, some of the colors having shallow light color kind of the thing. You can see this number 238, it's somewhat near to this 255, right? So at that time we will get somewhat the pureness of the white. You can see this pixel, it's related to or equal to some of the zero kind of the nature or zero kind of the number. That's why it's called as some of the darking coloring nature. You can also see some other colors, and with regarding all the pixel, we are going to be represented with respect to the each and every digits, or you can say each and every number in nature. So what will happen at the end? So we are understood it's going to be converted into the pixel, and also the giving the each and every pixel as some formatting. So at the end, you are going to be get as this matrix. At the end, you're going to be get as from image to this matrix. So why we are going to be take this image and plotting into corresponding the variance what we had. Suppose you are working on, let's take this diagram. Suppose you are working on this classification task, like with respect to the dog or cat, you are going to be classify it image, or you can say image class classification task. So this is the input we are going to be understood. How does that going to be represented in terms of the matrix equation? So you have a matrix corresponding to that. So how does this matrix going to be helpful at the end with respect to classify this is a dog or not? So further, we have different layers. Just now we learned with respect to the RNN concepts. So RNN concepts, we are going to be learn so many other different layers. As for the CNN concepts also, we are going to be learn different layer with regarding this matrix to use. So for that, we are going to be learn convolutional layer, and also something called as a max pool layer, and some flattened layer. We can also call it as a dense layer for that matter. And we have so many other operations also, like padding and striding and max pooling, and something called as a dropouts. So we will going to be learn these things will in detail, but as of now I will explain you some of the overview how does the matrix going to be helpful to understand in terms of classifying the dog or not. So if you go and see, this is a somewhat matrix we are going to be get with respect to the input image after passing to your convolutional layer. So convolutional layer is nothing but whatever the input image you are going to be passed, it consists of some kerneling nature. So convolution is nothing but we're going to be learn some of the patterns according to the whatever the input future you're going to be give in terms of the matrix format. So I will take this matrix, I will do some operation with regarding the some kernel. It will be consist of any kernel. It's come from the domain based kernel, or it may be consist of some predefined kernels like something called as Sobel. So these kernels are very important. This we can also call it as convolutional layer with respect to how many convolutions you require with regarding your task to do. So for that we going to be use these hidden layers, convolutional hidden layer one. This is the layer one, and for the max pooling has a layer two. For the max pooling has a layer 2. I will explain you max pooling and everything, how does that going to be helpful for just for understanding. This is the first hidden layer, this is the second hidden layer, and flattening is going to be helpful to get in terms of as array. So this is somewhat flattened layer. For the this is second layer, this is third layer, like that. So at the end you're going to be get as an array like this. It consists of 0 comma 1 results. 0 comma 1, 0 comma 1, 0 comma 1. So whoever having more number of like majority vote classifying with respect to dog or cat, so it will take as a majority vote at the end. Whoever having ones, it's going to be take that this is a dog. Whoever having the zeros has a majority vote takes as a cat. So like that is going to be classified at the end. And for that we have different layers, not only these three layers. These are simple to understand the basic overview how does from an input image to understanding the different layers and also getting the results at the end. So if you go and see what are the different layers or different hidden layers we have, and also the some of the operations. So we can also walk you this one of the best example we are going to be learned in the convolutional neural networks. So before that we are going to be learn some of the few other operations called padding and striding. So padding and striding, these are the simple operations in the convolutional neural networks. So in the CNN, we use something called as a padding. So first is why we are using padding and how to use this padding and when to use this padding, and also how does this going to be useful in the image concepts. So let's take this is the input image. You just converted it as a matrix. So just now we learned this in terms of whatever the grayscale image you had. So for that, you can take this is the input image. Let's for understanding purpose. So this is the input image you had something called 3 cross 3. I hope you understood, right? In formation of the matrix, 3 cross 3 is nothing but row and column wise. And also similar the 2 by 2 matrix, this is called as a kernel. So whenever you apply any convolution layer, it's going to be applied at the back end as a kernel mechanisms. This is going to be helpful to understand some of the patterns. This is going to understand some of the patterns with respect to your input. So that's why we are convoluting, you can say multiplying with respect to whatever the kernel you are going to be get. So something called as a Sobel kernel also, that is very popular, I can say. So that's going to be looks like the different kind of the ranges. So it consists of the 3 by 3 matrix as a kernel, which are having the values +1, 0, and -1, and +2, and 0, -2, and also the value corresponding to third, 0, and -1. So this is they have done some of this research on this kernel, and they also name it as a Sobel kernel for this. So it has not happened, I can say 1 day or 2 days. It maybe happened with respect to the decade of the experience and